This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host Gavin Henry, and today my guest is Nigel Poulton. Nigel is a Docker captain and trainer of many businesses all around the world. He is the author of two fantastic books titled The Kubernetes Book and Docker Deep Dive. He's a regular speaker and workshop leader at leading tech conferences and events such as DockerCon and KubeCon, and many others. Nigel, welcome to Software Engineering Radio. Is there anything I missed in your bio that you'd like to add?
Well, thanks for having me. And no, I think that sounded all right. I'm easy.
Okay, excellent. So I've broken the show up into three parts. So quite a meaty introduction to lay the foundation for the next two parts. We'll move on to Kubernetes technology, and then we'll try to discuss deploying an application on Kubernetes. So I'd like to start with an overview of what Kubernetes is and its history. For a deeper understanding of its history, I recommend the listeners to listen to show 246, which was John Wilkie's on the Borg and Kubernetes back in 2016. So Nigel, what is Kubernetes?
So elevator pitch, it is an orchestrator of microservices applications. And don't we just love a buzzword in the industry? An orchestrator of microservices applications. Let me just try and boil that down briefly. And look, we can go into more detail if you want. But I think the modern way of developing applications is different to what it was certainly 10 years ago. So we're building these applications that are built of like lots of small specialized parts that talk to each other via APIs. And in the modern business world, we want those applications to be able to scale up and down based on demand. We want them to be able to self-heal. We want to be able to push like rolling updates and things to them kind of during the business day without having to wait for long weekends and do loads of planning for like, I don't know, maybe one update a year. So, small moving parts in our applications, scale up, scale down, self-heal, push updates all the time. And we need something to sort of, without using a buzzword, but to orchestrate it or to oversee or manage that. And that's effectively what Kubernetes does.
Okay. Is it new?
It feels new, but it isn't really. So we've had it since, I think, the summer of 2014, and I've been using it ever since then. It is a big project or a big platform or tool. I think the core parts of it, like the core objects that are required to build and deploy applications on Kubernetes, they're really nicely baked and generally available and stable and all of that goodness. But of course, then you're going to get more, not edge case, but sort of newer features in the platform and things that are trying to push the boundaries that are a bit newer. So I think like the core components of Kubernetes are nicely baked and are all generally available. But of course, if you want to go to the bleeding edge with some of the newer features, then so parts of it are new without waffling and parts of it are super trustworthy and reliable. I mean, people are deploying applications to Kubernetes in production left, right, and center these days. So it's stable enough for a lot of people and it's mature enough. I'm always careful when I say, something is enterprise ready or is mature, Gavin, because terms like that, mature and enterprise ready, mean different things to different people and different organizations. So, of course, you always have to do your own research and your own testing. But look, people are using it in anger and loving it and hating it at the same time.
Thanks, Nigel. I think you touched on this answer in my first question, but what problem does it solve?
So let me give you an analogy here. And this is something that I give in trainings and things that I do all the time, right? Let me compare a modern microservices application to a football team. It can be American football or soccer. It doesn't really matter, okay? But that team is made up of lots of individuals, and each individual has a different role to play. So in soccer, somebody is a goalkeeper and other people are strikers and other people are defenders. Whether it's American football, there's somebody whose job it is just to kick, and then you've got a quarterback and wide receivers and all these different things, but they have to come together to work as a team. And a microservices application is very similar. So it might have like a web front end on it and a data store on the back end and some authentication and some middleware. And on their own, those elements, they're kind of great, a little bit like a goalkeeper in football or soccer is great, but on their own, they're not going to accomplish very much in a game. So the individuals of a team have to come together with a plan and play as a team. Well, in a microservices application, you've got all these different moving parts that need to come together to give an overall useful application experience to an end user. Now, in the football or soccer analogy, you have a coach comes along and organizes everybody into positions, arranges the tactics. If somebody gets hurt or injured, they swap them out with somebody else. If the score, if you're down towards the end of the game and you need to press forward more, attack more, you'll change the tactics, you'll change the personnel on the pitch. Kubernetes is very similar for a microservices application. Yes, all those pieces have to talk to each other, but they also have to be able to respond to business demand. So if it's Black Friday or something, right, and you're increasing demand on your system, well, Kubernetes can ratchet things up so that you have more instances of your web server and your backend to cope with demand. And then later on in the month, when things cool down, it can cool the application down and remove instances and things like that. But also then if things break, Kubernetes does what the coach on a soccer or football team does, is it takes the broken part of the application out of play and replaces it with a new part and keeps things ticking over. So basically, modern microservices applications have to be able to respond to business needs, have to be able to self-heal, all of that stuff. Kubernetes does that. And if you knew anything about VM sprawl in like a VMware world or like a virtualization world, you get the same with containerized applications or microservices applications. You get huge sprawl, and you need tools to be able to help you manage that, and Kubernetes does all of that as well.
Why is this a hard problem, and why is Kubernetes a better solution to something in an earlier generation of something trying to address that problem, that hard problem?
So I'll tell you the reason that it's hard. Back in the day, we would tend to deploy an application as a more monolithic application. And excuse me if I'm being a bit high level and I'm not going into detail here, but let's just call it a traditional monolithic application. You would have everything that application did, like the front end, the authentication, the logging, the database. Remember, I'm being super high level here, okay? But it would ship as a single binary or as a single installer, meaning that, if you ever had to perform an update on, let's say, the reporting aspect of it, quite often you'd have to take the whole thing down over a long weekend, high risk, everyone in the office, pizzas and coffee all weekend. And it was kind of painful. So we moved to this more microservices model where we say we take all of those different features of the application and we break them out into their own pieces so that we can have different development teams working on them. We can update the reporting system without having to touch the web front end or the database or whatever. And it's a much better model. It allows us to scale one element without scaling another part, update one element without updating another part. But because they're all talking via APIs over a network now, it suddenly becomes more complex. So you get a lot more capabilities from your modern applications. They're much better suited to modern business needs and requirements, but gluing it all together is way harder. Keeping everything talking is way harder. When you do that at scale, you can't have a human being doing it. You need a system to do it, and that system is Kubernetes. Now, to the second part of your question, and I'm not sure whether I'm necessarily answering your question here, but there were alternatives. So Docker Swarm, Apache Mesos, things like that can do very similar things to Kubernetes and still do. But the reason that Kubernetes grabs all of the airtime, it seems, is that it has so much momentum and so much almost universal backing from all of the cloud providers, from all of the enterprise data management companies, your Cisco's, your HPEs, your NetApps, people like that. Everybody is behind Kubernetes. So there are alternatives out there. And I'm not here to say that, one is better than the other. But Kubernetes is looking like the safest bet. Like if you're a business and you're like, we want to do this and we have to pick the right technologies, Kubernetes is a pretty nailed on safe bet. We know it's going to be here in the future. And we know it's developing and it's got a great ecosystem because everybody is on board with it. I hope that kind of answered your question.
Yeah, perfect. I think that has probably answers my next three, which is why is it winning and what is it driving adoption and how rapidly it is being adopted.
Yeah.
I think that's just because, like you said, everyone, well, with my business hat on, you get a bit tired trying to assess everything out there. And you get to a certain point, it's like, well, what's everyone using? What big names tick the boxes? Would you agree with that? That's what's driving adoption, is just everybody's talking about it, or?
Yeah, I think that is certainly a big part of it for sure. I think if we just wind the clock back a little bit, though, to give some sort of, at least from my opinion, and I've been in the ecosystem industry, containers and stuff for a while now.
What do you think is driving adoption then for?
Yeah, so if you think back to when Amazon Web Services was new, it came in from the left field and it started eating the lunch of your Microsofts and your IBMs and your Red Hats and your HPs and people like that. And they didn't like that, and they needed an answer to Amazon Web Services. Now, I think at first it's fair to say that we all thought that or hoped that was going to be OpenStack. And OpenStack tried very much to be like an open source version of AWS that would go toe to toe, feature to feature, but be something that you didn't have to be tied into a cloud provider for. And we did a lot of hard work around OpenStack, and unfortunately, no disrespect intended here at all, but it didn't end up becoming what I think a lot of us hoped it would be. And when I say us, I mean like, a lot of those traditional HPs and Ciscos and Microsofts and people really needed something to compete with NetApp. But OpenStack didn't become that. Again, in from the left field, and refer back to the episode that you had in the past on Borg and what have you, Borg and Omega probably. Google launched Kubernetes into the market. Now, we'll hear people will say that Kubernetes is the operating system of the cloud. And this, for me, is at the crux of why it's gaining so much popularity, right? When I say it's the operating system of the cloud, if you think about Linux or Windows being the operating system that sits on top of Dell servers and HP servers and Cisco servers and Supermicro servers, yeah? And one of the job of the operating system is to abstract what that hardware is below so that the user of an application doesn't have to care or even know whether the application is running on a Dell versus a Compaq or an HPE server. Yeah? Like, why would they want to care? They don't. And as long as your application will run on Linux or Windows, you can move that application to a different server hardware infrastructure as long as you're running Linux or Windows. Well, Kubernetes does the same thing. It says, we'll take your cloud infrastructure, AWS, Google Cloud Platform, Azure, all of the others, right? Or even virtual machines or physicals on premises. We'll take all of that, you slap Kubernetes on top of it, and as long as your application will run on Kubernetes, the consumer of the application doesn't have to care whether it's AWS at the bottom or your on-premises virtual machines, right? And by the same token, you can take your application that runs on Kubernetes and run it on Kubernetes somewhere else. So it does that abstraction that lets you run your code anywhere, and potentially, and look, it's not a silver bullet here, but it does make life easier when it comes to things like migrations as well. So as an end user, it's got a lot of things that are advantageous, but also the ecosystem needed something that was going to abstract Amazon Web Services, and Kubernetes potentially does that and does it for a lot of people, so that almost that AWS or Azure or GCP or IBM Cloud or Linode or wherever, right? It's abstracted, and it makes it easy for you to pick one cloud today, realize that you made a mistake next month and you want a different cloud, and move to it much easier than you could if you didn't have Kubernetes. Now, look, mate, I have a habit of waffling. I speak for a living, so I'm going to cut myself short there, and by all means, tell me if that didn't make sense.
No, that's good. We've just got a few bits left in the intro to sort of smooth that off. But yeah, that was a great answer. Thanks, Nigel. Just some nitty gritty. What's Kubernetes written in?
Oh, yeah. Okay. So predominantly it's written in Go.
Okay, Golang, yeah. What does it actually run on? So Kubernetes itself is an application written in Go.
Yeah. So it will run on Linux or Windows on anything underneath. Cloud instances, virtual machines in your data center, physical machines in your data center, as long as you have Linux or Windows. Now, for the most part, it's been Linux, but there's catch-up being played by Windows as well.
So you could have like an infinite mirror where you've got Kubernetes running on Kubernetes, running on Kubernetes, running on virtual machines, running on...
You might not want to do that. You probably can't.
No.
So what I would say is, like, if you want to build it yourself, so you have a bunch of hardware in your data center. Let's just take an on-premises example, but it could be cloud instances. You slap Linux on that, let's say, and let's say you've got 6 machines, and then on those 6 machines, you deploy Kubernetes. And you would probably, without us getting into too much detail here, deploy 3 manager nodes. That's your control plane that manages how the whole cluster works. And then 3 worker nodes where you run your user applications. But it's hardware be that physical tin in your data center or cloud instances or virtual machines, because of course they emulate hardware. You install an operating system, Linux or Windows, and then you go to work installing Kubernetes on top of that. Kubernetes forms a cluster or a substrate or whatever that you then deploy your applications to.
Excellent. So would a safe bet be some type of virtual machine platform which Kubernetes runs on top, or?
Yeah, happens all the time. Absolutely.
Okay, so you're still in the virtual machine world for some,
Yeah, for sure.
for those types of things. So where can we find it? How do we get our hands on Kubernetes?
Ooh, so lots of ways, and it's got lots simpler these days. So let me run you through maybe 2 or 3 scenarios. So let's say you are a developer or just somebody who wants to play around with it on your laptop. Hit Google and search for either Minikube or Docker Desktop. Personally, and it's just me, they're both great, don't get me wrong. Personally, I prefer Docker Desktop because it's click, 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 GUI. 2 minutes later, you've got Kubernetes up and running on your laptop, a single node cluster. So don't get me wrong, it's not for production, but you get to play around on your laptop. Just Google Docker Desktop, download it, Mac OS and Windows 10. 2 minutes later, you'll be in business. If you want to deploy it to the cloud and you're relatively new, the easiest way is a hosted Kubernetes service. Basically, that's where your trusted cloud provider and all the big cloud providers, in fact, just about every cloud provider has hosted Kubernetes. You go there and you say, I want a Kubernetes cluster with 3 manager nodes for high availability and let's say 5 worker nodes to run my applications. Build the worker nodes with this number of cores and this amount of RAM. Let's have this version of Kubernetes, and then you click the build button, pretty much. 2 minutes later, you will have a Kubernetes cluster that you can deploy applications to, and your cloud provider hides all of the hard parts of how do you make that control plane highly available and high performance, and how do you manage upgrades of the control plane. Hosted Kubernetes, your cloud provider does all of that for you. So an easy on-ramp. And then the third way would be to build it yourself, either in the cloud or in your own data center, and that's what we talked about before. You build your infrastructure, that can be physical machines, virtual machines, or cloud instances, lash an operating system on top, go and install Kubernetes.
Sounds good. Yeah, I've had a play with Minikube early last year sometime, and then I uninstalled it because it just sat with a high CPU eating my machine doing nothing. But that's probably me. I'll add in some show notes for the Docker Desktop. And what would be a good distro to use in the Linux world to run it on?
I try and shy away from recommending different products, okay? It's different for different companies. I tend to go with vanilla upstream Kubernetes as much as possible. But Red Hat has OpenShift. There are others out there as well. I'm personally quite a fan of Rancher. If you look up Rancher, I mean, they do great things with Kubernetes.
Yeah, they had a Rancher OS, didn't they? That's
they
kind of end of life now, I think.
Yes, that's right, yeah.
Okay, that's perfect. Well, I'll just scoot us on to the middle section after this last question. So given all the greatness of Kubernetes, what shouldn't we use it for?
All right, yeah, that's a really good question. So Kubernetes is definitely not for everybody. I think going forward, by the way, it will be the right choice for more and more people. But if you're a small shop with just a small handful of applications, Kubernetes is very much potentially overkill. It has a learning curve, and you have to be able to keep up with the updates and things like that. And in no way should your infrastructure, and I'm referring to Kubernetes here as infrastructure, right, demand more of your time than your applications. If that's the case, then it's probably a big sign that it's not the right choice for you. So if you are deploying something smaller and you're a smaller team and you're just testing the water with this, I highly recommend Docker Swarm. It does pretty much what Kubernetes does, but it's way easier to install and way easier to wrap your head around. But the chances are that you will either outgrow that in the future if you're growing your business, or as you want to do more advanced things, like what Docker Swarm gains in the simplicity and the ease of deployment category, it loses in the extensibility category. So to get started, and then if you think, yes, microservices applications are for me, and we're going to deploy more and more in anger going forward, then you might want to say, well, let's start moving to Kubernetes.
Yeah, that's where we're at in my business. We're on Docker Swarm for the past 2 or 3 years. So looking at all this stuff.
And it's a great product.
Yeah, I mean, you just set it and off you go, and it connects great with all the source code repositories and their CI/CD tools. I just love it. But like you've just said, you get to a point where you want to do sort of half and half upgrades and stuff like that. So there's a little bit of logic we have to check if things are working before the next step gets rolled out and things. And I think Kubernetes just does that much nicer. So we're going to move into Kubernetes terminology. We've covered its history. If listeners want to dig in a bit more, we've done a whole show on its history. A nice high-level overview for you there, Nigel, thanks. So I'd like to discuss the terminology we should use, what we should have in our heads when we're thinking about the example app we're going to talk about in the last section, which we're going to deploy on Kubernetes. So I've got around 10 questions in this section, so don't worry if we mix and match. But what are the main components of Kubernetes?
So I would say, like, zooming out 100,000 feet. So Kubernetes is a cluster that you deploy applications to, and that cluster is made of masters and workers. The masters, you generally speaking, shouldn't be deploying user applications to them. You should be reserving those to basically oversee the cluster and oversee your applications. And quite often I will refer to the masters as the brains of the cluster. So this is where all the like the scheduler runs there, the data store runs there that holds the state of the cluster and the state of your applications. It makes all the decisions as to which of the worker nodes to deploy application instances to. It's where all the logic sits to do the scaling and the self-healing and all the updates and things like that. Then you have your worker nodes, which are Linux or Windows, and you can mix and match these in a cluster. So you can run Linux and Windows applications side by side in the same Kubernetes cluster should you want to or need to. But those worker nodes all talk back to the control plane, reporting the status of the applications that they're running. So generally speaking, you'd want a highly available control plane, probably 3 or 5 nodes, and disperse those across different availability zones or regions in your data centers or your cloud, just so that if one of your regions or data centers goes down, you don't lose the whole thing.
And that's the usual odd number, isn't it? It's usually 3, 5, or 7.
Yeah, 3, 5, sometimes 7, just to avoid split brain scenarios. If you're interested, it's because, there's more than this, but it runs the Raft consensus algorithm in the background, which has a preference for.
Yeah, we've done a show on Raft and some other versions of Raft
right, super.
earlier this year, so I'll link to those. But if you want to drill down, they're really good.
And then I'd say as well, you want to deploy your worker nodes across different infrastructure zones as well. Just because, of course, as important as Kubernetes and the brains of the cluster are, look, the real meat of everything is your business applications. So you want those spread across infrastructure as well. And I would say that that's like maybe your 50,000 view of Kubernetes. It's about masters, it's about nodes. But then when you come to applications, and I don't want to steal some of your other questions potentially, but it's things like declarative manifests and desired state versus actual state or observed state and things like that.
That's perfect. And when you talk about the 3s and the 5s of masters and workers, and then your different, let's call them availability nodes, would you have 3 masters in each availability node? So do you split 1 in each?
Yeah. So generally speaking, let's say you are running a data center or a cloud setup where you've got 2 availability zones, just to keep it simple, yeah?
Yeah, say like Europe and US or something.
Yes, yeah. Or even 2 areas within Europe or within the US.
Yeah.
It doesn't really matter. I would say if you go with 3 masters, put 2 in one and 1 in the other. Or if you go with 5 masters, 3 in one zone and 2 in the other zone.
Okay, so you don't need the quorum.
Yeah, so as long as it can achieve quorum, let's say you've got those 2 availability zones and you've got 2 masters in one and 1 master in the other, and the network connectivity between the 2 goes down. Now, both sides now, zone 1, we'll call it, and zone 2, knew that there used to be 3 masters. Zone 1 can only see 2, and zone 2 can only see 1. Oh, I picked the wrong numbers there, didn't I? Anyway, one side can see 2, one side can see 1. They both knew there used to be 3. Well, the side that can see 2 knows that it has a majority, so it can form what we call a quorum. The other side knows that it doesn't have a majority, so it will effectively put itself into read-only mode. The applications in that zone will still run, but you can't perform updates against them because that zone knows that it doesn't have the majority of nodes. It doesn't know whether the other two are up or not. So it says, I'm going to be careful. I'm not going to write any updates to the cluster config or to our applications, just in case those other two are still running and they're writing updates as well.
Right, so we've got masters that hold all the information and workers that do the work. So we've done masters and nodes. What is a declarative model?
Okay, and this is a good one, I think, because at least for me, right, and I know it is for other people, it can be a really hard one to wrap your head around, especially if it's super new to you. So the idea of a declarative model is to say to the platform, and for us, that's Kubernetes, you say what you want and you let Kubernetes do the hard work. So we might say, we have an application and it's got, and we'll go dead simple, right, because we haven't got diagrams to help us here. It has a front end and a back end. And I want 5 instances of the web front end running, and I want 2 instances of a data store on the back end to keep it highly available. That is what I want, Kubernetes. And you put a little bit more in there, don't get me wrong. You say the web front end should be based on this container image, and the data store back end should be based on this container image. But I want 5 of the front end, 2 of the back end. You put that in a YAML file for Kubernetes, and you post it to Kubernetes, an HTTP post, yeah, because it's all API driven. Kubernetes looks at it and says, right, I'm supposed to have 5 front end and 2 back end. At the moment, when I observe the cluster, I've got 0 on the front end and 0 on the back end of this config. So I'll go and do the hard work of building 5 front end web servers and 2 back end data stores in a high availability formation. So Kubernetes goes away and it does all the hard work of pulling down container images, starting containers, joining them to networks, allocating network ports. Kubernetes does all of that for you because we've just said in our manifest, I want 5 web front-end servers. You tell them what port you want it on and what image. And then Kubernetes gets those up and running, and it stores that in the cluster store as its desired state. This is what we want. And then it kind of sits back, puts its feet up, and it watches the cluster and the applications. And it's kind of polling it all the time. Let's just call it polling. It's not quite, and it says, it's checking the cluster. I've got 5 on the front, 2 on the back, happy days. 5 on the front, 2 on the back, happy days. Then let's say something happens and we lose a worker node. And let's just say, to keep it easy, we have lost 2 instances of the web front end. So Kubernetes looks at the cluster. I'm supposed to have 5. Whoa, hang on, I've got 3. It's, general quarters, all hands to battle stations. We're supposed to have 5. We've got 3. We need to spin another 2 up. So it spins another 2 up and brings it back to that desired state of 5. And it does all the clever stuff of making sure, as long as you've got it configured properly, that it doesn't stick those 2 new instances on the same node that's already running another 2. If it's got a node that's running none in a different availability zone, it will, can be clever enough to go and spread them out like that. So that's the declarative state. You don't put together massive scripts that say, run this command to pull an image, run this command to start the container, run this command to expose it on this port. None of that. You just say to Kubernetes, I want this, go and make it happen. And by the way, if the state changes and I haven't told you to change it, you do whatever hard work is required to get it back to what I've asked for. And that's the model.
So my model is what I want the application to be. So
let me give you a quick example, right? So let's say you're building an extension on your house and you contract a builder to do it. It's unlikely, and some people might, but it's unlikely that you're going to say, right, in this extension, I want the foundations to be 3 feet deep or whatever with this type of cement. And then I want 17 courses of bricks with, whatever insulation you have. You generally don't do that. You will go with a more high-level plan and say, look, I want an extension with 3 walls. On the back wall, I want a big window facing the garden. And I would like an oven that's got 5 hobs or whatever. It doesn't matter. You don't go into the detail telling the builder how to do the work. You just say, look, this is almost a picture of the kitchen extension that I want. Go and build it and make sure it conforms to that. Instead of you giving the builder a massive long list of saying, go to this tradesman and get this type of brick. Go and get this type of you don't. You just say, effectively to Kubernetes, here's a picture of what I'm after. Make it happen. Make it so.
Yeah, so it's not quite a blueprint. It's just a level above that.
It is a level above that. Now, don't get me wrong. We do go into a bit of detail, like we tell it exactly which images to use and which ports to use and things like that. But it is such a difference from I think the key is that when things break, here's an example. When things break, Kubernetes knows what it's supposed to have, so goes and does the work to fix it back to that. Whereas if you don't take a model like this and you've built it with scripts, you're then logging on and you're manually firing up 2 new instances and you're choosing which nodes to put them on and you're working out which scripts to run. There's none of that. You tell Kubernetes what to do. If it breaks in the middle of the night, you sleep through it and you wake up in the morning and you're like, cheers, Kubernetes, for fixing it for me.
Cool. So the desired state is what the masters are trying to figure out what.
Constantly trying to work towards that desired state.
Yeah. And is that our desired state, how we want it to be, or how Kubernetes wants it to be?
No, that's us. So we say, we're kind of in charge. We say we want 5 web front ends and 2 database backends. That's my desired state, Kubernetes. Store that in the cluster store as effectively a record of intent. That's what I want. And then Kubernetes is constantly observing the cluster, making sure that what it observes matches what we've asked for, matches our desired state.
So my model there is I want a web server and a backend. This is what they're made up of. And the desired state is how many I want and what they should look like when they're live and up.
Yeah, absolutely.
And these are all in YAML, so yeah, another markup language. How do you test and verify that works, the YAML you've got?
Yeah, don't get me wrong. I mean, I do love YAML now, but it...
This was a question from one of the other hosts that has obviously got something going on at the moment. He's like, oh, can you make sure you ask how you test the YAML and verify it?
So Kubernetes does let you do dry runs of configs that you want of your desired states that you're wanting to push to the cluster. And we'll show you, what would happen if you were to apply it. It will feed back to you if, you've got your YAML syntax and stuff wrong. There are tools out there that will help you with that as well. I'm actually not an expert on what those tools are. I'm not an expert on YAML, but I do absolutely love it these days. I used to hate it, but I think once you wrap your head around it, then it's actually quite a friendly language, in my opinion. I much prefer it over full-on JSON.
Yeah, it's good just to have something that everybody uses, so you don't have to think too much. And I think that's what everyone goes to.
You know what I love about it as well, right, is that because we're defining our applications in this YAML file or YAML files, we're almost forced into a self-documentation. Like we're documenting to Kubernetes what we want, what the application should look like. So we've automatically got a document that, let's just say, developers can give to operations. Operations are always saying, document your apps, tell us what they're comprised of, what do you need? Well, because we're forced to do that, to tell Kubernetes to run it for us, we can also give that YAML file or those YAML files to operations and say, this is our application. And operations can read it, because YAML is not hard to read. Don't get me wrong, you can get your indentation wrong, and I do all the time. But, just reading it as a human is relatively easy. It's easy to look at a YAML file and say, okay, got a web front-end service here based on Nginx version whatever, and we're asking for 5 replicas of it. Oh, look, it's on port 8080, and we're pulling it from this particular container registry. Operations can easily look at that as well. You can onboard a new team member and say, go and start working on this application. Oh, well, what's the application comprised of? Read the YAML file. And in that way, it's like a super powerful tool, I think, for one of those more less technical jobs. You can onboard people, you can talk to operations, say, look, here's the config of our app.
Yeah, that's very true. One question I didn't ask when we were talking about desired state is when the masters are trying to get things into that shape, what would, in your experience, be some of the reasons that maybe one of the web servers just disappears? Would that be your application's done wrong, or the hardware goes, or?
Yeah, so I guess anything.
Is that a common thing?
Yeah, so you can have hardware failures of the infrastructure, like the server or whatever that's hosting the virtual machines or whatever. You can have network-related issues, and I'm fond of blaming the network. I always used to do that in my previous jobs. The Kubernetes agent, kubelet, that runs on each worker node could also have crashed for whatever reason. I guess any reason could cause any of your worker nodes to become unavailable. There's also the other thing as well, though, when you're trying to deploy or to scale an application, if you're doing it the right way, and the right way is to say every time you deploy an application or a microservice, you tell Kubernetes, what its resource requirements are, so the minimum in order for it to run, and what its limits should be, so capping it from taking over the whole system. If you're doing that with all of your applications and your cluster gets full, and you say deploy a new instance of an application or a new application, or you manually try to scale part of an application up, and it's demanding, or it requires more resources than your worker nodes have available, then you will start to see parts of your application go into the pending queue. So I don't think Kubernetes does anything special here, or I don't think it introduces any new types of faults or problems, but those are generally the types of things you will find from an infrastructure and an application perspective.
Perfect, thank you. Two last bits in this section before we move on to example application. We've managed to not mention pods or sidecars up until this point, and that would tie into my last one, which would be what is a deployment. So I think those three are probably best discussing together.
Yeah, let's rock and roll on them, yeah.
Go for it. So can you take us through what a pod is,
Yeah.
a sidecar, and I suppose a deployment would be deploying our intended application to Kubernetes. Yeah.
So I'll just wind it back a little bit, right? So you take application code, just written in your favorite language or whatever, and any of its dependencies, just like you would for if you were deploying to virtual machines or whatever. It's application source code and its dependencies. You package those two together, your app code and dependencies, into a container or a container image. Now, Docker runs containers natively on its own platform, okay? However, Kubernetes does not let you run a container directly on Kubernetes. Even though, and this can be confusing, even though Kubernetes is an orchestrator of containerized applications, you can't run a container directly on Kubernetes. In order to run that, it has to be wrapped in a pod. So it's quite often easy just to think of a pod and a container as being the same thing. The real difference is that a pod is just a very thin wrapper around a container that has a bunch of metadata that Kubernetes uses. So like you write your application and you package it as a container. But like I just said, Kubernetes really likes you to be able to say, well, what resources does this container require? And what resources should I cap it at on the node? And that's what you put inside the pod that sort of wraps around the container. So Kubernetes, it's got high moral standards. It does not allow naked containers to run on it. You must dress your containers in a pod, but it's such a super thin, lightweight wrapper. Now, there are instances as you become more advanced where you will deploy an application, but that application needs a helper. Look, let's use a service mesh as an example, okay? Let's say you're deploying an application as a container, but you want to be able to extract telemetry, and let's say you want to automatically encrypt traffic that goes into that container and comes out of it. Kubernetes has a very powerful model called the sidecar model. And there are different types of sidecars, but we'll keep it pretty high level. A service mesh, which is a buzzword these days, but that allows you to inject another container into your application that then in the service mesh model sits between your main application and the network and intercepts all traffic coming into your application and traffic that goes out to it, allowing you to get great network telemetry and things like that, but also enabling you, without touching your application code, to say, I'm going to force traffic in and out of this application to be encrypted. And you can do that because the sidecar is in between the application and the network. So the sidecar says, I'm encrypting everything. And your application doesn't even have to know. So you can, in a service mesh model, you can take an existing application that you've got and not have to touch that application code and be able to add network telemetry and mutual TLS for authentication and encryption without having to touch your app, because you just throw the service mesh sidecar into your application and it does it all transparently for you. Now, Gavin, tell me if you don't think that was well explained and we can go at it again.
No, that's perfect. That allows you, well, in my head, to add new things to a pod that's got a container within it.
Absolutely, yeah.
Different versions of it. I always understood, I think it was from your book, that the main thing you'd use it for is to go and fetch some new information that you might need to update something that's shipped with the container. That was one of the examples.
That's maybe a better example, right? More of a simple example. You might be running a static web server that you've built as a container, okay? But you update the content that web server is serving. And every time you make an update to that, you don't want to repackage and retest and redeploy your container. So you would just run that web server container, have a sidecar container alongside it that says, I am periodically pulling new content from GitHub or from a file server, wherever, and I pull it to the local file system that the web container is serving its content from.
So like your own sort of mini content distribution network, CDN or cache.
Yeah, why not? Yeah, that works.
Yeah. Cool. So what would our container choices be? It doesn't just use Docker, does it? Kubernetes. It can use anything that's OCI.
That's right.
Spec.
Yeah. So in the early days, Kubernetes heavily relied on Docker to do all of the low-level container functions like pull container images, start containers, join them to networks, things like that. But people want choice. So Kubernetes now has a pluggable container runtime layer called the CRI, the Container Runtime Interface, which basically says you can swap out pretty much any container runtime that you want to do your low-level pulling images and starting and stopping containers. Now, Kubernetes has just announced that it will not be supporting full-fat Docker going forward.
Yeah, I saw that tweet last week.
Yeah.
It's created a bit of a storm.
It's a storm in a teacup, or it isn't really a storm. So we've been moving towards this for a long time because Docker actually, I'll call it full-fat Docker. Full-fat Docker does, yes, it pulls images and it starts and stops containers and all that stuff, but it does a whole bunch more. And a bunch more that Kubernetes doesn't need it to do. So Kubernetes has always been moving towards a more cut-down version of container runtimes that just do what Kubernetes wants it to do. So for a long time now, Kubernetes has used something called Containerd, which is actually a Docker technology donated to, I think, the CNCF. And Kubernetes has allowed you to run Containerd instead of Docker for ages now, just doing those low-level functions. And a lot of people have been using Containerd instead of Docker for Kubernetes, and it just works. But look, the point is, right, you can switch and swap which container runtime is your favorite. And the reason, or one of the reasons you might want to do that is that out of the box, Docker or Containerd containers are not as secure as virtual machines. They share the same host kernel. It's much easier to escape the container and get access to the host than it is from a virtual machine. So there are other low-level container runtimes out there that have a different workload isolation model to Docker and Containerd. And you might need that for certain applications or for certain business units. So the ability to say, for actually running my containers, Docker's not a good fit for me or container's not a good fit for me. Maybe, I don't know, Kata containers or gvisor, one of the others, is a better fit for this application. Oh, I can easily swap it out.
Yeah, as long as it's OCI compliant.
Absolutely, yes.
So just to draw a line under the Docker depreciation, for anyone that's familiar with it, it's a depreciation of the shim, isn't it? That
I believe it is, yes.
Yeah, so it doesn't matter for most developers, really.
I would say, I mean, of course, always do your testing, especially if you're running in production, but it is almost such low-level plumbing that most of us don't even need to know. Don't get me wrong, important business applications, I would never recommend saying you don't need to know, but it's the kind of thing that most people won't even know has happened.
Great. So in relation to pods and sidecars, what is a deployment?
So a deployment is a higher level object that then wraps around a pod. Remember, a pod wraps around a container. And the reason for that is the pod will add metadata that Kubernetes uses maybe for scheduling and resource requirements and things. Well, then wrapping around a pod is a deployment object that brings things like the self-healing and the scalability. So the deployment object is where you say, I want 10 instances of this always to be running, getting back to our desired state that we talked about before. And it's a place where you can say, I want to update the version of the image that's being used, and the deployment will allow you to do that as a, buzzwords here, I do apologize, but as a zero downtime rolling update. So like, let's say you've got 10 instances running or 10 containers or 10 pods, and we'll update one at a time. We'll wait 5 minutes in between each update. We'll run some tests in between. The deployment object has all of the logic for that. So I like to think that that's where the magic happens. Generally speaking, you will always be deploying via a higher level object like a deployment. Now, I'll say one thing, a deployment object is the right way to deploy stateless microservices. If your microservices are creating and managing state or persisting data, then you will want to use a different object, maybe like a stateful set or something. But the point is it's higher level than a pod, and it brings magic to the game of self-healing and updates and rollbacks and things.
So you'd find the desired state within that deployment object.
Correct, yes.
And the declarative model is just the name for the thing of that.
Yeah, declarative model is just a buzzword for that ability to say, I want 5 of this, make sure that it's always looking like
the
that.
desired state, we could actually look inside the deployment config and see that. Okay, let's quickly summarize that and stop me if I'm wrong. The main components of Kubernetes are masters and nodes, worker nodes. There's an OCI spec to help people pick containers that would run. Containers do not run on Kubernetes. They live inside a pod, which is basically like you go into your IT department and say, my phone's not working, and they need some more context. So the pod gives you the context. So the sidecar helps you bolt on things or refresh things that are within that container that lives inside the pod. And the desired state is really what we want everything to be when it's live, which is contained within inside the deployment object. But there are other types of objects depending on how you want that desired state to be.
Yes. Yeah, works for me.
Excellent. So the last section, I've just made up an app. So I was going to ask you to give us an example of an app that would run on Kubernetes, and I think we've done a bit of that with a web server and backend. And that was actually my example too. I was going to ask to be taken through a public-facing API written in Golang, so it's a nice binary. It serves and saves some JSON over HTTPS, and it has a bit of a trickier backend, which is a PostgreSQL RDBMS backend. So there's some state in there. So my question would be, how would this be packaged, which would relate to a deployment object? So that would be my first question. Then my second would be, how do we deal with the persistent state of the database?
You've got 2 distinct elements of your application there, the stateless front end and the stateful back end. The front end would be built from your source code into a container wrapped as a pod and then wrapped into a deployment that says, I want however many of it. You've got a bunch of metadata that will help Kubernetes pick the right availability zones and all that kind of stuff. And you would push that deployment to Kubernetes, and Kubernetes will store it as a record of intent in the cluster store and deploy those, let's call it 5 instances of the web front end. And then it will sit in a loop watching the cluster, making sure that it's always got 5. Yeah, if something breaks, Kubernetes fixes it. Lovely. The second component of your application is a stateful component. Now, what we maybe weren't clear about before is that a deployment object only defines one pod or one application microservice. So we've got 2 microservices here, a web front end and a database backend. They can't be defined inside the same deployment object. Because if we were to say, I want 5 instances of it, what do you get 5 instances of? The web front end bit or the database backend bit? So if let's say you've got 5 different application components, you would need 5 different deployment objects or 4 deployment objects and a stateful set object. Each service in your application is wrapped by its own higher level object. Am I making sense there, Gavin?
Yeah, because otherwise, if you put them both in the same deployment, you'd have an API speaking to a database, and they'd all have different things they'd be serving up, wouldn't they?
Yes. Now, you can define them both separate objects in the same YAML file with 3 dashes between the objects, but they are different objects even though they're in the same YAML file. Now then, for your database backend, it depends what your database is and how you deploy it, but that would be deployed via a high-level object as well. Could be a deployment, could be a stateful set as well. And then you've effectively told Kubernetes what you want. We'll just say 5 of the front end and 2 of the back end, post those config files, those YAML files to Kubernetes, and Kubernetes deploys them and watches them. Now, within your applications, you need to have done the work to configure them to talk to each other. So obviously the API gateway at the front end will be exposing itself on a port. You've got to code that into your application, and you've got to put it in your pod spec as well so that Kubernetes knows which ports to expose it on. You will also need to tell it how to talk to the database on the back end. What port is the database listening on? Do I have any credentials that I need to present to the database in order for me to be able to write to it and read from it? Now then, the model here is that you don't code that runtime config into your application. You define it as a separate object. And the reason for doing this is instead of coding all of that into your web front end so that it knows the ports to expose itself on, the ports to talk to the database backend on, and more importantly, any secrets that are required to talk to the database, you don't want that shipping with your web server, because you package that as a container image and you store it in a repository somewhere. Now, of course, you can secure these repositories with RBAC and all that kind of stuff, but it's just not a good model to put that kind of configuration data into your production application. I mean, what if you need to change the port, or what if you need to change a secret? You then have to repackage your entire application, run it through dev and test and QA and all that kind of stuff, and then redeploy it. It's a bit of a pain. So what we do is we keep the application as simple as we can. It's a web server. It pulls some data. It exposes some port, and it talks to some database on some port at the back end with some credentials. We put that config and those credentials in Kubernetes objects. So generally speaking, we would put the config of the port and things maybe in a config map object, and any sensitive information like passwords and usernames into a secret object. And then at runtime, as part of that YAML configuration, we mount those config maps and those secrets into the web server so that it knows how to talk to the back end. Now, don't get me wrong, this is so much easier to explain when you've got diagrams and things like that. And I'm trying to be...
No, that's fine, Nigel. It fits nicely. In show 409 this year, we did a whole show on the 12-factor app, which talks about putting your secrets and things into the environment, and then your containers can see that environment. So I think that fits nicely with the config bit there. Okay, so the real tricky bit here is to make sure you map what ports need to be public, how your app's broken down, and really visualize how each bit speaks to each other.
Yeah. So I think like you kind of develop your application just as you normally would, but you just got to think of like that 12-factor application mindset of like, I don't store my config or my secrets in the application, but you write your application in the normal code that you write it in your favorite languages, using whatever the standard requirements and dependencies are. The only difference is like you just use different tools to package it as a container and to store your config and your secrets as Kubernetes config map and secret objects. And then a little bit of YAML to just bind them all together. But I mean, don't get me wrong, like the first time you do that, it is going to be probably a bit head exploding moment, but it's so simple once you've done it.
It does force you into the right way to do things, doesn't it?
And once you've done it, you're unlikely to want to go back and do it the other way.
Once we've done all this and we get it onto Kubernetes, just to refresh that bit, we're posting a physical file to the master nodes, aren't we? And then it goes off and does stuff with like curl or whatever GUI you're using, anything like that.
Normally you would use the kubectl command line tool, but it's all HTTP RESTful API. So curl, use whatever tool.
Yeah, and that could be built into whatever source code tool you're using that does whatever and post that. Okay, and I mentioned it would be an API with an HTTPS front end. Would we do that in the binary and run the HTTPS there, or would we put something in front of Kubernetes to do all this? Or does that depend on your model?
I'm going to say that depends on your model, and you can do either.
Okay. And where does DNS fit into all this and TLS?
I mean, so DNS fits in so many different layers. So obviously you will need, if it's coming from the internet, your connections are coming externally from the internet, you will need to have the correct DNS records out there in the public. But also within your Kubernetes cluster, so Kubernetes runs its own internal DNS service that it uses for service discovery. So in our example, we've got two services, a web front end and a back end. You are going to configure your web front end to talk to that database backend using a name. We don't ever use IPs. That doesn't change with Kubernetes. So you would include that name in the config map for your web front end, but then how does it get resolved to the containers or pods that are actually running that database backend? And Kubernetes has an object called a service object that does automatic DNS registration and does all of the name lookups and things like that for you. So it is automagic as long as you've configured it properly.
I like that, automagic. And is the TLS, like the mutual TLS, automatically there between things, or does it only do what you tell it to do? So you have to think about.
It only does what you tell it to do. And within your application and stuff, generally speaking, the preferred model is the service mesh model these days. It allows you to inject those sidecars that we talked about before that will sit between your application and the network and will automatically do the MTLS for you without you having to touch your application.
So it makes it much easier because it's just off the shelf.
Now, don't get me wrong, service mesh requires an amount of knowledge and expertise to deploy and manage itself. But that is, again, it is the right model. Instead of you touching your application code and having your developer of whatever service have to fudge some TLS stuff into their code that they're not necessarily wanting to do or very good at, bad model. Let's decouple the MTLS service, let's call it, from your application and just have it as a commodity that you can just throw into your infrastructure.
Perfect. And just to touch on persistent state again. So say we've deployed it with kube control, that QUBECTL command line tool. Masters are figuring out what to do. We've got the 5 front-end Golang API bits, and we've gone for a 3-node PostgreSQL setup. Now, the data that actually gets written into the database and lives on in a virtual machine or a physical server on the hard disks, what do we decide about that? How do we make sure that the next version of Postgres that's spun up has access to that data?
Gotcha. Okay, so you would configure Postgres or whatever it is, and I'm not a Postgres person, but you would configure that into its own high availability formation or configuration. And you would configure your web front end to talk to the live node or the master or however it works, the primary node, yeah? And Postgres will then take care of its own availability and things like that. The storage that backs that, increasingly going forward, you're going to use, I'm just going to call it external storage. Now, if you're on the cloud platform, that can be Google's persistent disks if you're on GCP, or it can be Elastic Block Storage if you're on AWS, or it can be whatever their NFS is. Because Kubernetes now has the ability for external storage systems, and look, that can be your NetApp and your Hedvigs and your EMCs and things, or it can be your cloud's own storage, and have that exposed into Kubernetes, just like you would expose external storage area network, SAN or NAS storage, into virtual machines in the past, so that it's decoupled from your server infrastructure, meaning that no matter which node you spin an instance up on, that external storage can be connected into that node.
So it's another abstraction layer that you can just document in the YAML and it'll take care of it.
Do you know what? Abstraction is like one of the key words of modern applications and modern infrastructure going forward. So Kubernetes has a model now called the Container Storage Interface, the CSI, which allows you to take external storage systems, have the life cycle of the volumes that they create be managed independently of your applications, and have those storage resources connected up to any application running on any node in your cluster. Dead easy.
And that just helps you grow nicely as well, because as your things change, you might need to redeploy stuff in the traditional world, and you're like, okay, we're going to have to get a new storage attached network, all this type of stuff. But because it's abstracted on this, it makes it easy just to not worry about that right now. Okay, and we're getting close to the end. Is there anything you want to mention about the network requirements for Kubernetes?
Yeah, so I'll take two things, right? So from a network perspective, right, when you deploy Kubernetes, for the most part, you will create a pod network on your Kubernetes cluster. And it's a VXLAN-based overlay network that is extended across all Kubernetes nodes in the cluster. And by default, it is wide open, right? So any application you deploy to Kubernetes goes on this pod network, and it's a free-for-all. They can all talk to each other. which is great. Well, I mean, it makes life easy, right?
Yeah, and a VXLAN is a virtual LAN. Like if you imagine it being a physical switch, you've got 48 ports on it. Anyone that plugs into that switch can listen to all the traffic because it's broadcasting round. So you really want to put
That's right.
some segregation between each port.
Yeah, so it lets you take hosts and nodes that might be on different physical underlay networks, and it lets you create a virtual network, like it tunnels through those. But you're right, it gives you effectively a wide open network that all of your applications can talk to. So you want to start then looking at network policies to start saying, we're going to start locking things down a bit, because while a wide open network is great when you're developing and testing, it's one less hurdle to jump over when you're building something to play with. Actually, in production, it's not what you want. So you need to start securing things, and network policies is a great place to start. The other thing from a security perspective I want to talk about, and it's not MTLS related, but it's the fact that pods or containers, you might be running 50 on a node. They all share that node's operating system kernel. So if one of them is compromised and gets access to the host's kernel, then all 50 containers on that node are at risk. And that's scary stuff in production, right? So I just want people to be aware, and this is a little bit advanced, okay? But as you're starting to deploy to production, you need to be looking at some of the other technologies that Kubernetes supports to start securing access to your host's kernel. And there are things like AppArmor and SE Linux, if you know Ubuntu and Red Hat Linux, okay? You can also do capability dropping. So drop the capabilities of the root user in your containers so that they don't have full root access to your container. Then you can also filter the syscalls, we're a bit low level here, but the requests that the application in your container can make to the host's kernel. And once you start locking stuff like this down, then it can be super secure. There's just an amount of work and an amount of testing that you must be prepared to do in order to really fully secure something in production.
Yeah, so you can go as deep as you need to there.
Really?
All right, I'll need to wrap us up now, Nigel. We could do another couple of hours, I'm sure. We did a nice show. Robert, the show editor, did a nice show with Rob Skellington on high cardinality and alerting and monitoring. Obviously, you've got the bit that you want to monitor your app and that it's healthy and everything. Would I be right in saying the key bits to monitor on Kubernetes would be the masters and the nodes, or is there something off the shelf we can look at for that?
Yeah, no, so you definitely want to be monitoring your cluster. I would just refer to that as infrastructure. That's your managers and your nodes.
Okay.
And you want, of course, things that will monitor your applications that have application intelligence in there. Security and monitoring are the two least interesting topics in the world for me. So I'm not an expert at them, but I will say that Prometheus is a great tool to start with. I'm not a Prometheus expert, but it's a CNCF project. It's massively used in the Kubernetes ecosystem. So you get all of the fact that it's a well-developed project, that it's being constantly worked on, that it's being constantly expanded, what it can do. So in the world of monitoring, Prometheus is a great place to start.
Perfect, thank you. Yeah, we've done a show on Prometheus, so I'll get that in the links. So I'm going to wrap up now. Obviously, Kubernetes is a very flexible beast, but it doesn't have to be too scary. If there was one thing a software engineer should remember from our show, what would you like that to be?
That Kubernetes, for all intents and purposes, looks like it is nailed on as the future of infrastructure for anything that wants to be cloud native or running in the cloud. But just if it's too complex for you and too much to bite off, take a look at Docker Swarm.
Okay, that'd be a good idea for another show, actually. Perfect. Was there anything we missed that you would have liked me to mention or thought should have been mentioned?
I don't think so. I mean, like you say, we could go all day.
Yeah, I mean, the title is Kubernetes Fundamentals, so I think we've done a good job. Yeah, I think that's it. Where can people find more about you? You've got your Twitter account, but what's the best way to reach out?
I'm pretty much at Nigel Poulton everywhere, Twitter, GitHub, LinkedIn. I'm more than happy to engage with people. I mean, I can't be free technical support for hard questions because I'm super busy, but I make a living out of helping make Kubernetes easier for people. So by all means, please reach out at Nigel Poulton. All of my stuff, my books, my video training courses, to book me for a company live stream and things like that, just go to nigelpoulton.com. And I'm going to finish by saying it's not hubris that I'm nigelpoulton.com or anything like that. It's just I used to be a Windows guy, and then I was a Linux guy, and then I was a storage guy, and I've been a network guy, now I'm a containers guy. I don't want to be like Kubernetes Nigel somewhere, because like in 5 years' time, I might be something different. So I just keep it easy. I just go with my name everywhere that I am. I don't plan anything.
So what, you're saying Kubernetes isn't going to be here in 5 years?
No, what I'm saying, no, that's a really good point. It will be. What I'm saying is, me as an individual, I'm a techaholic, right? And the best thing about technology for me is the mystery of it, and I love learning things. So once Kubernetes becomes super stable and no longer of interest to me, then I'll be on to the next interesting, groundbreaking thing.
Yeah, I get you. Perfect. Well, Nigel, thank you for coming on the show. It's been a real pleasure. This is Gavin Henry for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.